Welcome back to Basic Mathematics. In this video, we're going to be talking about dividing decimal numbers. Now that you've had some time to play around with how decimal numbers work and really get accustomed to them, we can turn to division, which is the place where decimal numbers really shine. It's also certainly the most complicated of the operations we can do on a decimal number. Let me get my head out of the way and let's start right in. I say that division is where decimal numbers shine because if you are dealing with division of just whole numbers, eight goes into 35. 8 fits into 35 four times. 4 times 8 is 32. You subtract that off and you get 3. In what we've done before, we've responded here and said, okay, the quotient is 4 with remainder 3. And that certainly does work, but it's not the only choice we can make. We can make another choice, which is to say that 35 is the same thing as 35.0. And now we have another digit that we can drop down and continue performing our division. 8 fits into 30 3 times. 3 times 8 is 24. Subtract that off and you get 6. All right, well, that's still a remainder, but we can play our trick again. Put in another digit. 35.00 is still the same thing as 35. But now we have another 0 we can drop down and we can do the division again. 8 fits into 67 times. 7 times 8 is 56. I'm running out of space. Let me scroll the screen so I can subtract that off and get 4. All right, in for a penny, in for a pound. Let's put in another 0 and we can drop that down and we can ask this time 8 goes into 40. How many times? 8 fits into 45 times. 5 times 8 is 40. That worked out exactly. There is no remainder. So finally, after inserting 3 extra digits, we are done. That's why division with decimal numbers can be the hard mode, but then the rest of the problem is fairly straightforward. We just take our decimal point and move it straight up. 35 divided by 8 is 4.375. 4 and 375 thousandths. In a sense, in this particular example, we got lucky. It doesn't have to happen that we end up with a remainder of 0 after a couple of steps. For some numbers, you just keep doing the same thing over and over and over again. The classic example of that is the division problem 1 divided by 3. We set that up. 3 goes into 1. Well, it doesn't. So we put in a decimal point and we add a 0. 3 fits into 10 3 times. 3 times 3 is 9. Subtract that off and you get 1. All right. Well, that's not 0, so we'll play our trick. We'll put in another 0 that we can drop down. And wait a second, didn't we just do this? 3 goes into 10 3 times. 3 times 3 is 9. Subtract that off and you get 1. All right, that's not a 0 remainder, so let's drop in or add in another 0 so we can drop it down. And 3 goes into 10 3 times. 3 times 3 is 9. Subtract that off and you get 1. Add another 0 so we can drop it down. 3 fits into 10 3 times. 3 times 3 is 9. Subtract that off, you get 1. We're not getting anywhere. This is what's known as a repeating decimal. And to indicate that it's a repeating decimal, we'll just take that 3 and we'll put a bar over it. Some numbers when you divide like this, will repeat after one digit. Some will repeat after 2 or 3 or 4 or any number. The number of steps that it takes before the number repeats is bound by the size of the number you're dividing by. So when you divide by 3, at most it can take 3 steps. When you divide by 111, at most it can take 111 steps. When you divide by 43, at most it can take 43 steps. And I hope you're listening to that and saying, wait, it's going to take 43 steps if I want to divide by 43? Well, it doesn't actually, but nonetheless, we generally shortcut at that point. So my instructions might tell you to take 576 divided by 43 and round to the nearest tenth. All right, well, setting that up, we can take 43 goes into 576. I am an idiot. I wrote the wrong problem down. I wrote down 576. I wanted to write down 567. Apparently, I've become slightly dyslexic. But now we can actually perform this division. 43 goes into 56. Well, that will fit one time. 1 times 43 is 43. Subtract that off and you get 13. 13 is smaller than 43, so we continue on, dropping down the next digit, which is 7. All right, 43 fits into 137. I'm not sure offhand, but I can always just take a quick estimate looking at the first digits. 4 fits into 13 3 times. So let's try 43 times 3 and see if it works. We might get lucky. 3 times 3 is 9. 3 times 4 is 12. And yeah, that looks like that'll work. 43 fits into 137 3 times. 3 times 43 is 129. And when we subtract that off, we get 8. All right, we need to keep going because the instructions told us to round to the nearest tenth. So let's put in a decimal point. Let's put in a 0 that we can drop down. 43 fits into 80. That will actually only fit once. 1 times 43 is 43. Subtract that off, and you get 37. Right. Now, our decimal point would go here. And it looks like we have, in fact, successfully rounded. But not really. Because remember the rules for rounding. If the next digit is 4 or lower, you round down and it would be 13.1. If the next digit is 5 or higher, you would round up and it would be 13.2. So we do need to figure out what the next digit is. 43 fits into 370. All right, I'm going to play the same trick I played before. Instead of thinking about 43, let's just think about 4. 4 fits into 36 9 times, so let's go off to the side and see what would happen if I multiplied 43 times 9. 9 times 3 is 27. 9 times 4 is 36, plus 2 is 38. Right? 387 is bigger than 370, so that won't work. So it must be one less. It'll be 8 times. 43 times 8. 8 times 3 is 24. 8 times 4 is 32, plus 2 is 34. So we get 344. Subtract that off, and you get 26. All right, just making sure that that worked out. 26 is smaller than 43. We're in good shape. But that next digit is 8, and that's what we needed to know, because 8 tells me round up. And so I'm running out of space. Let me scroll back up to where the problem was actually stated. I get that 567 divided by 43 is approximately 13.2, rounding to the nearest tenth. So that's the basic idea of dividing decimal numbers. One thing that I haven't looked at yet is what happens if the numbers themselves contain decimal points. And that's where things get messy. That's where I said at the beginning that this is the annoying part of the process. So let's take a look. Put that decimal point in the wrong place. At 2.5 goes into 1.28. To start off, I'm going to use the same trick I used when we talked about multiplying. If I'm thinking about 1.28 divided by 2.5, that's approximately the same thing as 1 divided by 3, which came out at that 0.3 repeating we were just talking about. So I know what the solution should end up as before I do anything else. And I can use that information to make sure that I put the decimal point in the right place. But the rule is actually fairly straightforward. What we need to do is move our decimal points over a little bit. 1.28 divided by 2.5 turns out to be the exact same thing as 12.8 divided by 25. All right, that's weird. Let me step out of the way so we can actually look at the problem. Why is that going to be the case? Well, think about place values. I know I'm looking way over here to see that I'm pointing at the right place on my green screen. 1.28 is nearest hundredth. That's divide by 10 to get to tenths and divide by 10 again. 2.5 is nearest tenth, so that's divide by 10. So I divided by 10 twice, I divided by 10 once. One of those divide by 10s will cancel out when I divide this whole thing, which is why in our final result, we only divided by 10 once. Right? That's a kind of loopy way of thinking about it. Also, I've gone horribly blurry. There we go, back to being less fuzzy. But that's the logic behind what's happening. Practically speaking, I find it easiest to look at it in this direction. We had 2.5. There is a digit after the decimal point in this number, and that is always a problem. So we have to slide the decimal point over one place so that there's not a decimal digit in the number outside. The number inside, we can have a decimal point. That's not a problem. It's not going to just be zeros at the end, but we've dealt with numbers that have decimal points a couple of times already. All right, so now that I've gone through all the logic, we're taking a look now at 25 goes into 12.8. And of course, it doesn't. 25 does not fit into 12, so we have to look at the whole thing in one go. 25 fits into 128. All right, multiples of 25 are pretty easy if you've ever handled change. right? 1/4, 25 cents, 2/4 is 50 cents, 75 cents, $1, $1.25, $1.50. You count up all of those, it was the fifth one that looks like it's going to be the most promising. 5 times 25 is 125. Subtract that off and you get 3. All right, put in a 0 so we can drop that down and we can keep going a little bit. Why not? 25 fits into 30 once. 1 times 25 is 25. Subtract that off and you get 5. Put in one more 0 that we can drop down. 25 fits into 50 twice. 2 times 25 is 50. Subtract that off and you get 0. All right, so 12.8 divided by 25 is 0.512, which is not the same as the 0.33 we got when we estimated, but it's pretty close. And because 12.8 divided by 25 is 0.512, that means that 1.28 divided by 2.5 is also 0.512. Again, I know that that's a little bit goofy. It takes a little bit of getting used to, but that is the process for dividing decimal numbers. All right, so with that, I'm going to end this video, take some time practicing doing the division, and I'll see you next time.